And now we will talk about the turning effect of wind and trim on ship engine. So we already studied about the pivot point. Now we will see how the wind affects. So mainly the wind is affecting on the what you call windage area, which is above the water. So wind turning effects will depend on the vessels on the turning lever. Now what is the turning lever? Turning lever is the distance between your pivot point and the windage area. So this is the center of the exposed area, which is the windage area. This is the pivot point which we already saw. And the distance between the two for a imaginary lever, this is the what you call turning lever. So both are these imaginary points, and windage area is the centroid of this exposed area, and it is denoted by letter W. Now this first conditions what we are saying is the ship is stopped, even keel, and in loaded condition. In loaded condition, more part of the ship will be underwater and less part in the exposed. Now next is the bird's eye view, where we are seeing the same ship, and you can see the distance between the pivot point and the windage area W is very less. That means the turning lever is very less. Because the turning lever is very less, so there will be very negligible turning because there is no lever for turning. So wind, if it is coming, the ship will not turn. Maybe it will move bodily towards on the leeward side. Now wind is on the port beam, as you can see. So even our next berthing case, we will see the wind is from the last berthing case we saw, offshore wind was on the port beam. So it will take like this. Now in this case, there will be the ship will turns very slightly to port, but it will be negligible because there is a very weak turning lever, which is distance between P and W is less. So usually the ship will lie with both winds, with wind about 2 points forward of the wind. So wind this up, in this case the ship will come to a balance at around 2 points on the winds. Then when the ship is moving ahead, we know that pivot point will move ahead 1/4 from forward, 1/4 of the length, and because of this, there will be a good lever between the pivot point and the center of windage area. These are all imaginary points, and because of this, again, there is a big turning lever, and you have port beam wind, and this is a lever. So this wind is moving this W this side, this part of the vessel this side. So the ship will turn on the port side. So at beam wind, with moving ahead, the ship will turn to port. So you will have to give it will be violent turning, and we have to give bold rudder and engine movement to control the swing of the ship. Now when the ship is moving astern, we know pivot point will move astern, 1/4 from the astern, and there is not quite big, but there is a good lever. So again, when the wind is moving, the wind will push this lever into this side, and the ship forward will go to starboard and stern will go to port. So stern will go into the wind when ship is moving astern, and bow will go into the wind when the ship is moving ahead. But remember, this is even keel case and loaded condition. But in instant, the effect will be less moderate. Now let's see the effect of trim. Now effect of trim is when the vessel is having a stern trim, and because there is more part of the forward part which is more exposed to the water, so windage area will shift forward, and because of that, when the ship is moving ahead, the turning lever is again reduced, so ship will hardly turn. Already when there was forward, the turning lever was violent, But in this case, the turning lever will become less. So when you are in loaded condition, if you have more trim, the ship will swing less because of the wind. Now, if you go astern, again the lever will be increased because stern trim windage area is forward, and when you go astern, the pivot point will come here, and because of that, there will be a very big lever, and there will be a big turning point. So especially with the more stern trim or ballast condition, if you go astern, you will move violently because of the wind. So we have to be very careful in ballast condition. Empty ship will move violently with the uh, wind, especially because you turn violently with the wind, especially when going astern. Now opposite will happen when the ship is down by head. So similar case, ship is down by head. So W will move aft because more aft part is exposed and ship is moving ahead. So P will be here. So there will be the biggest turning lever, very big turning lever when ship is down by head, and when this wind is acting from here in the port beam, will turn the wheel and bow will go into the wind. So it will be very violent turn. Now windage area is calculated by wind force upon 1000 meters square, V square upon 18T, and V is equals to the wind of the ship speed. That is, notice